Okay, so we completed till over here. Like we found out the variation, yeah, for the case of ring, isn't it? We had calculated two things like rod and ring. We completed the derivation of rod and ring particularly. Semicircular ring is also done. And then we did the variation, graphical variation of potential on axial point for the ring. For potential and electric field on the same graph and all, isn't it? Okay, so let us start doing some problems. Then I'll move ahead. Why not? So you can see the picture clearly. So what it is said that okay, I have such a kind of semicircular ring over here in which the charge density on ring varies as lambda is equal to lambda naught sine theta. Right or not? Question is find the net electric field and potential at the center of ring. At the center of ring. Do it. क्या बोल रहा है कि the charge density means these charges which are present on this ring are varying like lambda is equal to lambda naught sine theta. Okay. Uh, you can change the orientation. Okay, let me just delete this picture. Let me draw mine picture. So I have a ring. Word or not? Okay, and the theta I'm considering from positive x-axis. This is my theta. Okay, in which the positive charges are present, and that charge is varying like lambda is equal to lambda naught sine theta. So do the calculation. What? Yeah, yeah. This theta is subtended from the center. 1 minute. Wait. Let me draw it perfectly. Of course, the radius will be from center, isn't it? Now it will. Is it visible like it's from center and radius is r? Okay. 1 minute. Just do it. Yeah. Yeah. Try to do it. Yeah. So here we can't solve using the normal trick method which I gave to you. Why not? Yeah. So what I will have to do is I'll have to if this is my radius r, I'll have to first consider a small element of charge over here, isn't it? Right or not? Yes, which will be having charge how much? dq, and it should sustain angle d theta at the center, isn't it? So then the length of this arc is how much? R d theta, isn't it? Now, due to this dq, the electric field will be present in this direction, isn't it? And for that electric field, I'll have two components. And if this angle is theta, this angle will be also how much? Theta. So this is my small electric field D. I'll have D cos theta. Then 1 minute. And this will be my D sin theta, isn't it? Now you can even consider a diametrically opposite point, isn't it? So due to that also d cos theta will be there. So you will see that from all these points, from all these different charges, the horizontal component will equally balance each other out. So electric field along x direction will be what? Zero. Yeah, means along x direction I'm saying, because of this component there will be one more. Similarly like this I'll have here and there and all, isn't it? So along x direction I'm saying it will be how much? Zero. But along y direction, Ey will be what? Integral sum of this, all these d sine theta, isn't it? So d will be how much? 1 by 4 pi epsilon naught q dq divided by distance is r square into sine theta, isn't it? Now, if you look into dq, so here lambda is given. Now, lambda is equal to a small charge by a small length, which is r d theta, isn't it? And lambda is varying like lambda naught sine theta. So, I got my relation for dq. dq is lambda naught r sine theta into d theta. Are you able to get me or not? So, this Ey will be how much? Just put it over there. K, I'm writing 1 by 4 pi epsilon naught as K. Void or not? So K into K will be outside and dq is lambda naught r. So lambda naught 1 r and 1 r will cancel this square term. So lambda naught r, lambda naught by r. Okay. Integral sine square theta into d theta. That will be my term, isn't it? Are you able to get me? Is that clear? Now I can write sine square theta as what? K lambda naught by r integral 1 minus cos 2 theta by 2 into d theta, isn't it? And theta varies from 0 degrees till pi. Are you able to get me? So you know that I'll get Ey as k lambda naught by r, and this is integral d theta. So it will just change to theta minus cos 2 theta, theta by 2 actually. I'm taking the LCM common. Cos theta will change to sine 2 theta, and that will come as 4 over here, isn't it? 0 to pi. So look over here, this sine theta for any value of pi and 0, it will be 0, isn't it? Okay, so look over here, see, I'll do a stepwise step. See, I can write this as what? Integral 0 to pi 1 by 2 d theta, 0 to pi cos 2 theta by 2, isn't it? Now you got the idea. So Ey is equal to k lambda naught by r. So this will become 0 because it is going to come as sine. Void or not? Okay. And this will be just theta. So it will be theta by 2, 0 to pi. So it is equal to k lambda naught pi by 2r. That's my electric field for the semicircular ring. Are you able to get me or not? Which for which the lambda varies as lambda naught sine theta. Are you able to get me or not? Is that clear? Now, similarly, try to find out what is the potential. What is the potential? So potential will be very simple to calculate. You know that potential is simply means what will happen? 1 by 4 pi epsilon naught r will be common and integral dq. Why? Because all the charges are at distance how much? R. Are you able to get me or not? So 1 by 4 pi epsilon naught r. Just replace lambda naught r sine theta d theta 0 to pi. R cancel. So it is k lambda integral sine theta. So which is equal to minus cos theta and 0 to pi. So this is k lambda minus cos pi plus minus minus it will be plus, isn't it? Plus cos 0. So it is equal to twice k lambda. Are you able to get me or not? Is that clear? So that's my potential at the center for a ring on whose the charges starts to vary. Are you able to get me? Okay, आगे बढ़े. ठीक. Now look over here. All right. There is one question. Okay. Now see that. This is my ring and it is placed like this way. Right or not? The ring has radius r. Okay. And the charge on the ring is q. Right or not? Plus q basically. बोल रहा है कि if I place a charge minus q charge and mass m at a distance x from the center of the ring, okay, then question is if charge minus q comma m is released from rest, then find question number 1. If x is less than r, if x is too much less than r, then time period of SHM. Second question, if x is equal to root 3r, then velocity of charge minus q at center. Without. Yeah. Try to do it. Try to do it, then I'll move ahead. Okay. Yeah, it's easy. It's really easy. If you think, it will be very, very easy to solve. Think you can easily solve it. Can you do it? Okay, let me do it. Uh-huh. Yeah, something like that will be it. Acha. So look over here. If I do the first question in which it says that x is too much less than r, isn't it? So so E axial on the ring is how much? What was the electric field? Minus. It will be K. I am asking about electric field. It will be KQ. What will be the electric field due to the ring at this point X? KQX by R square plus X square to the power of 3 by 2. This will be my electric field now. If this is my electric field, then force on the charge, so F is equal force on the charge minus Q. Minus Q is a moving charge, so minus Q into this electric field of the ring, isn't it? Which is minus Q into K capital Q X by R square plus X square to the power of 3 by 2, isn't it? Okay. So therefore, now look over here. So this implies, or therefore we can say that this force, if x is less than too much r, then x square is similar to 0, isn't it? So force on minus q will be just k capital Q small q x by r q, and that too in towards the center we can say by removing minus sign, isn't it? You can remove minus or you can keep it, no problem like that. Okay. Yeah, so if I force is minus means mass into acceleration, which is k capital Q small q by r cube into x. So that means time period. This is going to be my, if I put m over here, that will be my omega square, isn't it? So omega square is equal to K by Rm. It will be R cube m. That is going to be my omega square, isn't it? So the time period is opposite of that 2 pi root under mr cube divided by K capital Q small. That's my time period of oscillation, isn't it? Okay. Did you did second question? Can you do the second question? Try it. Second question. Once again, it's talking about finding velocity. So I have told you always to use work energy theorem, isn't it? Yeah. So work energy theorem, not about fixed or moving. If it is not even fixed, then you have to use one more equation, which is of law of conservation of moment. Yeah. So here energy, yeah, because my particular electrostatic force is a kind of which kind of a field? Conservative field. So here force is towards the charge itself, towards the center itself. So work energy will be same like kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final, because my electrostatic force is a conservative force, isn't it? Here its velocity was 0. So its kinetic energy is also 0. So initial kinetic energy is 0. Then initial potential energy. So potential of the ring over that point into the charge will be my potential energy, isn't it? So if x is equal to root 3r, the formula of potential over there was that k q by root over, root over r square plus x square. That was my potential energy, isn't it? So that is r square plus x square is root 3r. How come it will be half? Means I have used, I have used square root over here or not. And then I have to multiply with the moving charge, which is minus q. Final kinetic energy half mv square, isn't it? And final potential energy, the potential will be kq by r into moving charge minus q. So equation will be k capital Q means minus k cap small q. This is root 3r square, that means root 3r square. So this becomes 2r plus, if I just bring this over here, so k q by r is equal to half mv square, isn't it? So this becomes how much? If I take the ratio 2, so it will be uh, k capital Q small q divided by 2r, which is half mv square, 2 cancel, and I got my velocity of the charged particle, which is root under k capital Q small q divided by mr. That's my velocity of the charged particle at the center. Got it? Is that clear? Okay. Then do this question. Okay. Uh, Line charge means we have an arrangement like this way. This goes till infinity. Semicircular ring. Okay. The radius of the semicircular ring is r, and Everything has charge density plus lambda. Well done. Okay. Question is, find the electric field at origin O. Find the electric field at origin O. Do it fast. 1 minute. Try to do it. You have 2 minutes of time. Okay. You know, do it. It says just separate every part. Okay. Yeah. Yeah. Okay. Just you do one thing. See, this is my one of the rod. This is my another rod, isn't it? Which are going till infinity. And then there is my semicircle. Yeah, that's the easiest task. So for this, the electric field is will be in this direction and this direction. So look over here. Just go to the case of semi-infinite case. What? Can you tell me once again? Where is that? Yeah. So look over here. This is my semi-infinite case, isn't it? So you can see that the electric field along this side is k lambda by r, and this side it is k lambda by r, isn't it? I'm not talking about resultant electric field. I'm talking about two components of it. ठीक है? So look over here. So for this, one electric field is along this direction, another electric field is along this direction. Similarly, for this rod, one electric field will be in this direction, another electric field will be in this direction, isn't it? Agree. And for semicircular rod, the electric field totally will be in downward direction. This will be E is equal to k lambda by r, and this will be also k lambda by r, isn't it? Because this distance is r only. Similarly, this will be k lambda by r, and this one will be also k lambda by r. And for any circular arc, the electric field was given as what? K lambda by r, 2k lambda by r sin theta by 2. यही था ना formula. Yes. So here angle is 180, so this becomes just E is equal to twice k lambda by r. Are you able to get me or not? So look over here. This electric field is k lambda by r. So they will, in the horizontal direction, they will cancel each other. Similarly, along the vertical direction also they will cancel each other, isn't it? So what is my net electric field at the center? E net is equal to 0. For all the situation. Okay. For this rod, this net electric field is like this way. For this rod, the net electric field is like this way. And this is downwards. For the ring, this is k lambda by r as per the diagram. This is k lambda by r. This is twice k lambda by r. And this is also twice k lambda by r. So how much is the net electric field? 0. Because from all the direction it's getting cancelled out. Are you able to get me or not? Is that perfectly clear? Okay. So this was the case for the condition if I have any kind of symmetry, any kind of object for which if I want to find my electric field for different cases. Are you able to get me? ठीक है? चलो. Now, so we discussed the first case, rod, then the second case ring, then the mixed case of rod and ring. Now, let us discuss about electric field due to uniformly charged disk. ठीक है? अब ध्यान से सोचो. Let's suppose if I have a disk, right or not, and I want to find, this is my disk, and I want to find the electric field, right or not? So let's suppose if I draw, now you can find the electric field at the on the surface of the disk also, center of the disk also, and on a perpendicular region, isn't it? And similarly, I can calculate my potentials also, isn't it? So let us see, let us understand what is actually happening. Okay. So बोल रहा है कि if the disk is uniformly charged okay with surface charge density sigma. ठीक है, with surface charge density how much? Sigma. Then if I want to calculate my electric field at any point due to this whole disk, so first I need to construct a triangle over here on. So this angle is theta. Let's suppose on the axial point this distance is given as x. Okay. And radius of the ring is r. Okay. And this is my origin O. And I want to find my electric field at that particular point. So let's suppose if I have defined sigma, if the disk was charged with some kind of charge q and radius r, so sigma will be exactly equal to charge by surface area of the disk or not, which is equal to pi r square. ठीक. So if I know my sigma, then it's very easy to find the electric field for this disk. How? I'll tell you the direct answer, then I'll do the derivation. This electric field is given as E is equal to sigma by 2 epsilon naught. Okay. Bracket 1 minus x by root under x square. No, no, 1 minus. Yeah. R square plus x square. But if you look into r x by root under r square plus x square, that is nothing but 1, that is cos theta. So this electric field is given as sigma by 2 epsilon naught 1 minus cos theta. Yeah. No, no need to write anything else. These two are only formulas. Are you able to get me or not? Yeah. So let's suppose, why to consider that there will be too many things. 1 minus, here there is no cos square theta. Now you can replace it by 2 sin square theta and all. Yeah. 2 sin square theta by 2. Yeah. So now the point is, if x is equal to 0, isn't it? Means if I come at the origin. So look over here, if I make my x to be 0, this term gets cancelled, but this term still remains over there. So still my electric field is present, which is equal to sigma by 2 epsilon. But the main question arises that, sir, where is the direction of this electric field? At the center. Tell me. Yeah. Now remember, for a charged disk, the electric field always points away from the surface of the disk. So it is always along the normal of the plane of the disk. Are you able to get me or not? ठीक है. Okay, now the next point is I want to define my potential also. So as usual, first we will define, then we will go for derivation, isn't it? So the potential, you know that potential is just the integration of this. So potential for the ring case, for the disk case, sorry, is given as sigma by 2 epsilon naught bracket root under 1, sorry, root under r square plus x square minus x. That's my potential due to my particular case of disk. Are you able to get me or not? Now let's suppose if you make your x to be 0. So potential at center is also not 0. It is simply sigma r square by twice epsilon naught. Are you able to get me or not? So we got to know that two things are there. First thing is electric field is equal to sigma by 2 epsilon naught and potential at the center, which is sigma r square by 2 epsilon naught. Are you able to get me? Now you can see that particularly I can draw the graph of this. So for the case of electric field and for the case of potential of the disk, let us try to draw the graph. So this is my electric field and this is my potential with respect to distance x. Okay. So look over here. When x is 0, electric field is maximum sigma by 2 epsilon naught. Then it starts to decrease by cos theta factor of. So electric field varies like a cos theta factor. So it goes like this way. Okay. So this is sigma by 2 epsilon naught when x is 0. Potential in the sense it will not vary that much faster because it is just varying with respect to x, isn't it? So it will go very, very slower, but it will be less than the electric field because look over here at x is equal to 0, it is sigma r square by 2 epsilon. Okay. Sorry, it will be more than the electric field. It will be like this. Is that clear? Go ahead or not? Are you able to get me? Okay. Why I am drawing like this, both the things? Because in some of the cases, they will not ask you that draw the individual graph. They will ask you the convergence of both the graphs. Are you able to get me or not? So you can clearly see the difference. One is more, one is less. Are you able to get me? Acha, sorry. It's not r square. It will be 1 minute. Actually, root under r square is just r. So it will be sigma r by epsilon. Are you able to get me? So in NEET 2018, there was a question that what is the potential at the circumference of the disk? Now you can see that electric field is perpendicular to the disk. So for all the disk, the potential should always remain constant or not. According to equipotential theorem. Yeah, so whatever is my potential at center, that must be potential at the circumference. So therefore, the potential at the, yeah, 2 epsilon. Yeah, so potential at the circumference of disk is sigma r by 2 epsilon. Is that clear? Okay. Okay. Let us understand one more case of it. And let's suppose this time uh, uh, I have okay. So I have a hollow disk. Let me fit it perfectly. Yeah, now it can be seen clearly. So I have a disk which is hollow in nature. What kind of nature it is? Hollow. Word or not? Means it's like you can see that ring, something like ring, but it is a thick ring. You can term it like that way. Word or not? Yeah. So inside radius is R1, outside you can consider, no problem regarding that. And outer radius is R2. Okay. And then the question is very simple. If I consider a point at a distance x from the center of the ring, then find the electric field and potential over there. Do it fast. If then find the potential and the electric field at that point. Yeah, you have to find the potential. Ha. Hello. Hello. Hi बाबू. हाँ बोलो. तुम कहाँ हो? अच्छा. ओके. ओके. कोई बात नहीं. Can you tell me how to do it? It's easy actually. If you think now, it's very easy. Should I do? Let us see. So there is an easy trick for handling this thing. I'm really telling you, it's very easy to understand. You want to see how? So these are our two discs, isn't it? One taken out part. This is my original part from which I taken out this part, isn't it? So I call this as plus sigma and I call this as minus sigma. So whenever you get these kind of confusions, treat like whenever you get hollow kind of thing and they are symmetrical in nature. So treat one to be having plus charge density, another with other having minus charge density. Are you able to get me or not? We can't consider the hollow as plus. Why? We will not consider it. See, this is a trick to understand because that's an taken out part or not. I'm taking out this part out of this big square, big disk. Word. So that's why I'm treating it like that minus sigma represents that I have taken it out. Okay. Yeah. So let's suppose this is distance x. So for both of them, the distance x will be same, but one will be of radius r1. Another one will be of radius r. So yeah, so simple. E net is nothing but electric field at 1 due to first one. I call this as E1. And for this also it will be in same direction. But the charge density I'm considering it to be negative. Okay. I'm not changing the direction. Okay. And this one will be E2. So E1 plus E2. E1 will be sigma by 2 epsilon naught bracket. The formula is what? 1 minus x x by root under r square plus x square minus sigma by 2 epsilon naught 1 minus x by root under r square plus x square. So this is the most easiest trick to understand any vector quantity of symmetrical nature. Are you able to get me or not? Yeah. So then E net is simply, if you solve it, sigma by 2 epsilon naught, this term got cancelled, and I'll be left with sigma by 2 epsilon naught, and it will be something. Acha, 1 minute. The radiuses are different now. Yeah. So this is R1, sorry, R2. That is R2, and this is R1. Yeah. So this will become positive. So equation is x by root under R1 square plus x square minus x by root under R2 square plus x square. That's my electric field at origin, at point P. Are you able to get me or not? Similarly, I can talk of potential. V net, V net at point P will be V1 plus V2, isn't it? So that will be once again similar thing. I can treat it like, so R1 square plus x square as square root minus x, x ही था ना? Yeah, this is V1, this is R2, not R1. Okay, minus sigma by 2 epsilon naught root under R1 square plus x square minus x. Right or not? So once again, sigma by 2 epsilon naught into x term will get cancelled, and V net, therefore V net at point P is simply written as sigma by 2 epsilon naught root under R2 square plus, it will be sigma by 2 epsilon naught root under R2 square plus x square and then it will be minus of root under R1 square plus x square. Is that clear or not? Are you able to get me? Okay. So now, yeah, always whenever there is a very good idea, I'm telling you, whenever you get this hollow kind of bodies in symmetrical kind of objects, utilize this process of considering one as positive sigma, another one as negative sigma. Is that clear or not? ठीक है. So what I'm going to do today,